Hello all, let us now look at a demo for perceptron algorithm. As we have seen in the course, we know that perceptron algorithm is used for simple binary classification problems. That is, when we have problems that have a class C1 and a class C2 that need to be separated by a hyperplane. We have also seen in the course that perceptron algorithm converges only for linearly separable data. That is, for cases when the data is of this form C1 and C2, that is, the data are not linearly separable, that is, we cannot find a hyperplane that can separate class C1 and C2, the perceptron algorithm fails. So, suppose we have a set of inputs that are linearly separable. Then, using the perceptron algorithm, we can find a weight vector W such that W transpose X is greater than 0 for all inputs X that belong to class C1, and W transpose X is less than or equal to 0 for all inputs that belong to the class C2. That is, in the case of inputs, say we have a class of this form and another class of this form. Say this is C1, this is C2. Similarly, maybe the two classes are of this form. In this case, we see that the data is not linearly separable, but as the distance between the two of these moons increases, that is, the data is of this form, then they become linearly separable. So, now assuming the data is linearly separable, that is, say of this form, we can find a weight vector W that can classify them into two different classes. So, the basic steps in the algorithm are, we need to find the inner product between the weight and the input. Suppose the inner product is greater than 0 for an input that belongs to class C2, then we see that it is getting misclassified. Therefore, we need to update the weight in this form, that is, we need to reduce the weight as learning rate times the input. On the other hand, if an input belongs to class C1, but the inner product between the weight and the input is less than or equal to 0, it is again getting misclassified into C2. Therefore, the weight needs to be increased. So, these two steps form the basis of the perceptron algorithm, that is, the weight change is based on these two steps. Now, let us look at a simple case of the logic gates. We know the truth table of the AND gate, that is, say we have inputs x1 and x2 and the corresponding label as say y. For the cases of 0 0, 0 1, 1 0 and 1 1, we know that the output is 0 for the first three cases and the output is 1 only when both the inputs are 1. So, we consider all these three inputs as class 0 and this as class 1. So, we have plotted the points here. We see that at 0 0 it is class 0, at 0 1 it is class 0, at 1 0 it is class 0 and at 1 1 it belongs to class 1. We see that the perceptron algorithm is able to find a hyperplane that can linearly separate or identify these two classes. Similarly, let us consider the OR gate. From the truth table of OR gate, we again know that the two classes are linearly separable, that is, we have x1, x2 and the output y. So, when you have 0 0, the output is 0, but for all the other inputs the output is 1. So, here this belongs to class 0 and all these belong to class 1. So, this is in the case of AND gate, this is for OR gate. So, since the data is linearly separable, in both the cases perceptron algorithm was able to converge and identify a hyperplane that can separate the two classes. Now, let us consider a new problem. Let us consider data of this form, that is, we have two classes, this being C1 and this half moon being C2. The data is generated such that in class C1 you have 1000 points and in class C2 you have 1000 points. So, the radius of C1 is given by Rm, the inner radius of C2 is given by Rin and the outer radius is given by Rout. So, the ratio of Rm is to Rin is to Rout is in the form of 1:2:3. So, you can use various combinations, as you can use either say 1, 2, 3 or 1 say 3, 6, 9 and different combinations to generate the data. So, now this D value here decides the separation between the center of this class C1 and the starting of the class C2. So, now let us see what happens by varying various parameters using this data set. First, let us consider what happens by changing the value of D. So, here D is the separation between the center of the circle in class C1 and the starting of class C2. So, in the first case we see that when D equal to 0, that is they both are at the same level, the data is not linearly separable. Therefore, the perceptron algorithm is not able to classify the data points uniquely, or that is we are not able to classify C1 separately from C2. Similarly, in the case of D equal to 1, again the data is not linearly separable and therefore, we are not able to attain 100% accuracy. Again in D equal to 2 case, the same thing happens, the data is not linearly separable. Now, as we keep on increasing D, we see that when D is equal to 3, the data is linearly separable and therefore, the perceptron algorithm is able to find a hyperplane that can identify or classify the data points as C1 and C2 with 100% accuracy. So, now having identified that with D equal to 3, we are able to get the data to be linearly separable, let us perform a few other experiments. Now, fixing the value of D is equal to 3, let us see what happens if we have different initial conditions of the weight vector. So, in the first case we have chosen the weights and bias of this form. We know the data is linearly separable. We can form multiple hyperplanes. So, given a weight vector and bias of this form, the perceptron algorithm is able to converge to a hyperplane that makes the two classes separable. So, we see here in this case, here we have used a different combination of weight and bias, we are again able to find a hyperplane. In this third case also we have used a different set of weight and bias and still we are able to find a hyperplane. So, this shows that the hyperplane obtained is not unique for a given set of data. So, you can try out with different combinations of weights and bias and see for yourself what are the types of or what are the equations of the hyperplane that you will be obtaining. Now, let us add Gaussian noise to both of the clusters or classes. So, for each class we add Gaussian noise with mean 0 and variance ranging from 1 to 3. So, in the first case that we see here, we have added noise with mean 0 and variance 1. So, we see that the data is very noisy and the data has become not linearly separable. So, because of this our perceptron algorithm is not able to converge or find a hyperplane that can separate these two classes. So, even though the data was initially linearly separable with D equal to 3, with addition of noise the data points are getting mixed and therefore, they are not linearly separable. As we increase the variance from 1 to 3, we again see a more disturbed behavior, that is both the clusters or classes are overlapping with each other. Therefore, there is no way that the perceptron algorithm can find a hyperplane to distinctly classify the data points from each of the class. So, one problem with perceptron that we see is that in the presence of noise, it tends to fail, or it is not able to find a hyperplane that can classify the points. Now, let us observe what happens by varying the learning rate that we have in the update rule. So, now first let us fix the learning rate to be 0.1. In this case, since the data is already linearly separable, that is, we have chosen d equal to 3, the perceptron algorithm will converge. Now, let us see the number of steps required for convergence. We see that with 12 steps the network is able to converge, and we are able to find a hyperplane that separates both the classes. Now, let us increase the learning rate eta from 0.1 to say 0.5. We see that even in this case, finally the perceptron algorithm is able to find a hyperplane that can classify the data points. We see that in this case it requires just 10 steps. So, we might come to a conclusion saying as we increase the learning rate, maybe the epochs or the number of steps required for convergence decreases. Now, let us further increase eta to say 0.7. Again, the perceptron algorithm is able to find a hyperplane that will classify the data points into class 1 and class 2. Now, we see that the number of steps required again has gone to 12. Number of steps required for convergence has gone to 12. Even though it appears as though there is an inverse relation between the number of steps and the learning rate, there is no relation that is present based on the learning rate and the epochs required for convergence. You are encouraged to go through the proof that we have done in the course and see that eta does not finally appear in the term which gives the number of steps for convergence. You can try out with different values of eta and experiment and see the number of steps required for convergence by yourself. Additionally, you could do a few other things using the same data. You could run the algorithm in online mode as well as batch mode and see the number of steps required for convergence and try out all the variations that we had till now: vary d, vary eta, add noise, use different initial conditions, initial weight and bias conditions. Varying all these parameters, you try to identify which is better, either batch mode or online mode. Also, you could try to randomize the sequence of inputs that are present or presented to the perceptron algorithm. Say the first time you give say x1, x2, x3, x4, maybe the next time you give x2, x1, x4, x3. So, try to identify if the order of inputs matters for the algorithm. Try to ponder upon what happens for randomizing of the sequence in batch mode. Does it actually give any difference? If not, why? Trying out all these would actually give you more insights on the batch mode and online mode of the perceptron algorithm, and it will make you more comfortable with this algorithm. So, we encourage you to try out all these. We have given you the values of the ratio in which you can choose multiple values for RM, Rn and Rout. You can choose various values of D. You can probably have another class maybe over here. Instead of this being C2, you change C2, and instead of just a circle you could have this being C1, this being C2. As the classes go inside, is the data linearly separable or not, or what is the minimum distance that you need for them to be linearly separable. You could try out all such experiments and this will make you more comfortable with the perceptron algorithm. Thank you.